Students, this is your teacher that the course, and in this video we'll be taking our time to look at the chemical properties of acids. In the previous video we looked at the physical property of acids where we talked about sour taste, solubility in water. We talked about changing the color of litmus paper from blue to red. And in this video we'll be looking at properties of an acid in terms of change in chemical structure. To start with, there are 5 properties of an acid. 5 of them. Number 1, as you can see in this place, number 1, acid react with base to form salt and water. Acid react with base to form salt and water. Number 2, acid reacts with metals, reactive metals, to form salt and hydrogen gas. Hydrogen gas is liberated. Number 3, acid, they normally react with carbonate salt to produce salt, water, and carbon dioxide. So carbon dioxide will be liberated as a gas when acid reacts with carbonate salt like sodium trisulcarbonate 4, potassium hydrogen trisulcarbonate 4. Acid reacts with sulfate 4 salt. You got them trioxosulfate 4 salt to produce salt, water, and sulfur 4 oxide. Then finally they react with metallic sulfide to produce salt and hydrogen sulfide. So we're going to take a look at all these 5 properties one after the other and explain it in depth. The first one is the reaction of acid with base to produce salt and water. Acid normally reacts with the bases to produce salt and water. I might be wondering, what is the meaning of base? What are bases? Bases are oxides of metals. You know metals. Metals are elements that are ending with that have valence electron of 1, 2, or 3. You call them metals. Or the transition element, they are metals. So oxides of metals are bases. So for example now, calcium is a metal. The oxide of calcium will be called a base because it's an oxide of calcium. That's the meaning of base. Sometimes a base can also be hydroxides of metals, like calcium now, for example. The hydroxide of calcium is also a base. So when you see hydroxide in a compound, that compound is a base. And if you see oxygen in front of a metal, it's also a base. So acid reacts with this compound to produce a salt and water. You call this kind of reaction a neutralization reaction. A reaction in which acid will react with base to produce salt and water is called neutralization reaction. Don't forget that. It's very, very important. Neutralization is an acid-base reaction. What is neutralization reaction in the first place? It's a reaction between an acid and a base to form a salt and water. For example, in this place, HCl, hydrochloric acid, is an acid. Sodium hydroxide is a base. You have seen OH, meaning that is an hydroxide. OH is a radical, like you all know, like that you're already familiar with. So observe how the reaction takes place. The H picks the OH. You can see that the H picks the OH to give us HOH. HOH is water, H2O. And the Na picks the Cl to give us NaCl, a salt. So that reaction in which an acid reacts with a base to form a salt and water is known as neutralization reaction. Neutralization reaction. So examples that we have here are all acid-base reaction. You can see in this place H2SO4 is an acid. Of course, you are familiar with that. NH4OH is a base, a weak base. Now, see how we are going to get our product, because it's very, very important for you to know how to arrive at the product of acid-base reaction. See, hydrogen here is one entity, SO4 is another unit. In the base here, NH4 is a radical that you are aware of. OH is another radical. So what you do is this: the H, because it's a plus, we pick up OH. That will give us H2O. See, H from here and OH from here. Don't worry, forget about the number of times the hydrogen is occurring now. So both of them have valency of 1 1. You know, H is H plus, OH minus is minus. So they have valency of 1 1, which makes them H2O, HOH. Now in the second instance, the SO4 we pick up NH4. So NH4 is positive. If you check your radical table, is a plus, means that the valency is 1. SO4, if you check your radical table, is 2 minus, means that the valency is 2. Did you see that? So you are going to exchange your valencies. That will now give you NH4 2 times, SO4 1. So that will be giving us NH4 2, NH4 2, SO4 only 1. So that's how we arrive at the salt. NH4 2, NH4 2, SO4 only ones. So take note of that. Let's see another example here. Let's see this example. Calcium hydroxide and H2CO3. H2CO3 is a weak acid. Don't forget that. So you split the acid into two, the hydrogen and the radical part. Split the base also into two, the calcium and the hydroxide part. So you can guess which of them will hydrogen pick. Hydrogen will go and pick the OH to form water. Now here, calcium will pick CO3. From what you already know, calcium is number 20, so it's a 2882. The valency of calcium is 2. CO3 is a radical with a 2 minus, so the valency is 2. So since there are 2 they should cancel out, so you'll be having a CaCO3, and that's why our salt here is a CaCO3 and water. Now let's look at another example here. NaOH and H2CO3. The first thing you do also, you split the NaOH into the component NaOH, then H2CO3 also into its component H, then CO3. Of course, you know what will be picking what now. H will always go and pick the OH because H is plus, the OH in that place is minus. So they pick each other based on sign. Sodium is a metal, that's a plus. CO3 is a minus. So sodium will pick CO3. So here now, when our sodium picks up CO3, the valency of sodium is 1. Because sodium is number 11, that will be 281. So the valency is 1.